I'm going to talk about cosine similarity. But before getting into cosine similarity, I'd like to speak about the most basic approach that we could think of to measure similarity between two documents. Let us imagine that we are given two documents, item 1 and item 2, and we were asked to find the similarity between them. So, the most basic approach that we could think of is counting the maximum number of common words between those two documents. So, if those two documents were given to us as vectors projected in a multi-dimensional space, the same thing, counting the maximum number of common words, is called as Euclidean distance. So, Euclidean distance is basically measuring the distance between those two vectors. But this has an inherent flaw. So imagine if these two documents, item 1 and item 2, have different sizes. Imagine that item 1 is very large in size compared to item 2. So the vector of item 1 extends way way farther than the item 2 vector. So when we calculate the Euclidean distance, then the distance is longer than usual. So even if the documents are speaking about the same topic, the Euclidean distance doesn't agree with that. So to overcome this flaw, we can use cosine similarity. Cosine similarity is an similarity metric that is used to measure the similarity between documents irrespective of their size. So cosine similarity basically measures the angle between those two vectors instead of the distance between them. The cosine similarity begins with finding the cosine of two non-zero vectors. So here is the formula for dot product of two vectors, a dot b, where a dot b is equals to magnitude of a multiplied by magnitude of b, and the multiplied by cosine of the angle between them. So the cosine similarity can be defined as from the given formula, cos theta equals to a dot b divided by the magnitude of a multiplied by magnitude of b. The output range of the cosine similarity function will range from -1 to 1, where -1 is non-similar, 0 is orthogonal, and 1 is similar. Here I have put together an example, document 1 and document 2, where document 1 is deep learning can be hard and document 2 is deep learning can be simple. And I also put together a table with the words written down from both the documents, and I have also written down the frequency of those word occurrences in both the documents. So now I am going to imagine these both documents word frequencies as a vector of 6 dimensions. So, and I'll assume the doc1 as A and I'll assume the doc2 vector as B. So this is the cosine similarity formula. So to find the cosine similarity, we have to divide the dot product of A and B by both the magnitudes multiplied. So finding the dot product, it's 4, and the magnitude of A is 2.23 and magnitude of B is 2.23, and finally the similarity measure is 4 divided by 2.23 into 2.23, which is 0.8. From the given answer, we could say that both the doc1 and doc2 are 80% similar. Cosine similarity has a variety of applications in the field of data science. They could be used as plagiarism detectors, recommendation systems, information retrieval, and also text matching. It can also be used as a loss function while training neural networks. Well, cosine similarity is inherently good because even if the documents vary by size, even if they're far apart by size, they might be inclined towards each other, having a high similarity. Cosine similarity finds this cosine similarity gives the similarity accurately regardless of their sizes.